Okay, so what we're going to do for this section, for section 7.2, is to graph ellipses. Now, 7.1, we graph parabolas. We graph parabolas in both quadratic form and in both standard form. What we're going to do today is we're going to graph what's called an ellipse. Now, ellipse has a very special definition, and I'm not going to get into the technical math definition of it, but I just want to describe what an ellipse is. Essentially, what an ellipse is you're going to take a cone, and what you're going to do with this cone is you're going to slice it diagonally, where you enter one side of the cone and you exit the other side of the cone. Now, when you enter and exit one side of each of the cone, you're going to create a slice that's something sort of like what's pictured here. Now, essentially, the slice, if you were to take a look at the slice, your ellipse is going to look something like that. Essentially, what an ellipse is, and this is a very, very general term, but an ellipse is just an oval. Now, if you take this oval, an oval is essentially just a squished circle where you have one diameter is larger than the other diameter. Now, if you take this oval and you perfectly round it out, you get a circle. Now, essentially, a circle, to create a circle from a cone, is you take this cone and you slice it perfectly horizontal. When you slice that cone perfectly horizontal, that's how you're going to create the circle. If you slice the cone a little bit at an angle, that's how you're going to create an ellipse. Now, the ellipse and the circle are going to have very, very similar standard form equations. Now, the standard form of an equation for an ellipse is going to be x minus h quantity squared. Again, notice how the h is paired with the x over what's called a squared plus y minus k, again k is always paired with the y, quantity squared over b squared equals 1. This is one version of the standard form of an ellipse. Now, the second version is almost the same. The only difference is that the denominators are going to be switched. So x minus h quantity squared over b squared plus y minus k quantity squared over a squared equals to 1. Now, a couple of things that I want you guys to notice. First thing is, your ellipse or your circle on the right hand side is always going to have to equal 1. This is always going to have to be the case. Now, the second thing is, it's always going to be addition in the middle. If it's anything other than addition, you're not going to have an ellipse or a circle. Now, a couple of things that I want to also define is your a squared and your b squared. Essentially, a squared is going to be the bigger denominator. B squared is going to be the smaller denominator. Oops, I spelled. A squared is going to be your bigger denominator. B squared is going to be your smaller denominator. Now, the only difference between these two standard forms is if the bigger denominator, or in one version, the bigger denominator is underneath the x, the other version, the bigger denominator is underneath the y. Now, that is going to determine the type of ellipse you're going to have, because there's going to be two types. There's going to be what's called a vertical ellipse, and there's going to be what's called a horizontal ellipse. Now, if the bigger denominator is underneath the x-axis, you're going to have a horizontal ellipse. If the bigger denominator is underneath the y value, you're going to have a vertical ellipse. Now, their orientation is exactly the way the name suggests. If you have a horizontal ellipse, what that means is the ellipse is going to be longer in the vertical or in the horizontal direction. If you have a vertical ellipse, your ellipse is going to be longer in the vertical orientation. So, if the bigger denominator is underneath the x, you're going to have a horizontal ellipse. If the bigger denominator is underneath the y, you're going to have a vertical ellipse. Now, as far as orientation is exactly the same. If the bigger denominator is underneath the x, the orientation is going to be horizontal. The bigger denominator is underneath the y, the orientation is going to be vertical. Now, how we're going to graph the ellipse is going to be based on what the h value is, what the k value is, what the a and the b values are. So let me give you a couple of definitions. First of all, the center. The center of an ellipse is right in the middle. Now the center is always going to be h comma k for both a vertical and a horizontal ellipse. Now keep in mind, just like the parabola, your h comma k is always going to be opposite of what's inside of your equation. So the center of the ellipse is always going to be h comma k. Now I'm going to leave the focus alone for a second. I'm going to go to what's called the vertices. Now what your vertices are, there's two types of vertices. There's the vertices and there is the covertices. Your vertices are going to be the vertices or the corner of your ellipse that is farthest away from the center. So these are going to be your vertices. Now your covertices are going to be the smaller, I don't want to use the term corners, but that's essentially what they are. They're the smaller radii, I guess we could call it that way. So these are going to be your covertices. So here are your vertices, which is the farther distance. Your covertices are going to be the shorter distance. Now this is the way we're going to find the vertices. So what we're going to do with the vertices is we're going to look at your A and your B values. Now keep in mind, your A and your B values are always going to be the denominator. Your vertices is going to be A units away from the center. So that means that your center, your vertices, sometimes books call them your major vertices. Your major vertices are A units away from the center. Now your covertices are B units away from the center. Now this goes to both a horizontal and vertical ellipse. So A units away from the center are going to be your vertices. B units away from the center are going to be your covertices. Now there's two other definitions, your major axis and your minor axis. Your major axis is essentially the longest diameter. So here is our major axis. I always use the term long diameter or major diameter. That's technically not the correct math term, but that's sort of the easiest way to describe it. Now your minor axis is the shorter diameter. So here is your minor axis. Now same thing goes for the vertical ellipse. Your major axis in a vertical ellipse goes vertical. So here is our major axis, and our minor axis goes horizontal. So minor axis. And we could sketch those in if we want. So here's our major axis, here's our minor axis. Here's our minor axis, here is our major axis. So major axis connects the vertices. Your minor axis connects the covertices. Now, final definition is what's called your foci. Now, before I talk about the foci, I want to talk about the relationship between A, B, and C. There's going to be another variable that I want to define, and that's what's going to be called C. Now, C, by definition, is going to be A squared minus B squared, or, I'm sorry, it's always going to be A squared minus B squared. Essentially, what your C value is your bigger denominator minus your smaller denominator, quantity squared. Now, what the C value does is, the C value gives you your focus. Your focus is C units away from the center. Now, this is important though. It's going to be C units away from the center along the major axis. So, the focus of an ellipse is you go along the major axis and you're going to go C units away from the center. Now, an ellipse actually has two focuses, also called foci or foci. So here is one focus, there is the other focus. Your focus is always going to be along the major axis. Now, on a vertical ellipse, since our major axis goes vertical, our foci everybody says a little bit different, is going to be, again, C units away from the center.